Hello students, welcome to this video. The purpose of this video is actually to get you to be thinking about continuity. So I've actually provided a link to a Khan Academy video that I think does an excellent job of teaching you about continuity. So I actually recommend you to go watch that video before watching mine because I really like his descriptions and his visual representation of helping you understand continuity. But after you've watched that video and gotten kind of a good idea of what it is, I want to give you some formal and informal ways to think about continuity. So continuity. So a basic, very easy, informal way to think about continuity is it is a function that has no holes. It is a function that has no gaps. It is a function that has no jumps. And it is a function that has no breaks. So if you are looking at a function, and I always hear if you can draw the function without lifting up your pencil, then it is probably a continuous function. So if I were trying to draw a linear function, I would draw a line. I can draw that in one stroke, or an exponential function or a quadratic function. But if I have to draw a function where I lift up my pencil, then I would know that this thing is not continuous. So to put that into better mathematical language, there's three things that we're going to check. We are going to check if f at c is defined. So that makes you think, okay, well, what in the world is she representing as c? Well, some background information. C is going to be a number. So C is a number in the interval A to B. Okay? And F is going to be a function that is a part of that interval. So that is its domain. So we know that we are continuous if F of C is defined. We then also want to look at the limit. So if we can find the limit as x approaches c of f of x, if we are able to find a value, meaning that this limit exists, then that means that we must be continuous. And the third thing that we're going to check for is if the limit as x approaches c of f of x equals f of c. Okay. If f is continuous at every point in the interval, then f is continuous on the open interval A to B. And so again, the key here is that we are talking about an open interval. Okay, so these are the guidelines to ensure that I am continuous on an open interval. So again, this is the formal way of saying continuity means there's no holes, no gaps, no jumps, no breaks. You are able to find values for each x that you are looking for. Now, I may also care about continuity on a closed interval. So I want to make sure I provide you with those guidelines. So again, we're going to be talking about a function f, but now we're going to be looking at the closed interval A to B. So we are looking at the limit as x approaches a from the right of f of x, and that needs to equal f of a. And we are going to look at the limit as x approaches b from the left. I don't know if I said that right. Let me rephrase. I'm sorry. The limit as x approaches a from the right of f of x equals f of a, and the limit as x approaches b from the left of f of x has to equal f of b. If this is true, then you are continuous on the closed interval. So the key here is looking at the closed interval. Again, the Khan Academy video shows you great examples, real examples of how this comes into play. So I hope that this provides a good idea of the formal definitions for you, and I want you to watch that video to ensure that you are seeing some visual representations of continuity. But I feel that you would be really good knowing that continuous means I don't got to lift up my pencil. There's no jumps, no gaps, no breaks. So you you just have this continuous function, no holes, this point is missing, but I'm going to make up for it with another point as you would in a piecewise function. None of that, then your function is going to be continuous. I hope you found this video a little helpful, and as always, if you have questions or concerns, please don't hesitate to reach out to me.